Alright, so we're ready again to do a problem, another book problem. Determine the positive real root of ln of x to the fourth equals 0.7. Alright, well, of course, the first thing we're going to have to do is turn this into a problem that set it equal to 0. So we're going to say ln of x to the fourth minus 0.7 equals 0. Alright, well, so that'll be, and when we set that equal to 0, that'll be the root. And we're going to find that root graphically using 3 iterations of the bisection method with initial guesses of 0.5 and 2, and using 3 iterations of false position method with the same initial guesses as in B. Okay, and hopefully I typed it in right this time. So, graphically, well, this should be easy. We'll switch over to MATLAB, and let's see, it's saying between 0.5 and 2, so let's go, between, we'll just go between minus 10 and 10 again to do this. ln of x to the fourth minus 0.7. So x equals minus 10, 0.1, let's get 0.1 to 10, y equals LL log, it's just log, that is the ln, log of, I don't know if we have to put that in for, y equals log of x to the, was it cubed? No, x to the fourth, minus 0.7, okay, plot xy. Okay. Okay. So we have this big dip here. Let's go. Hold on. And again, let's just plot our plot x zeros size x. Yeah. And let's do it in red. I think I'm missing one parenthesis. That looks better. Okay. Now we've got it. Okay, so exactly. So we can see exactly what's going on here. We have one root over here, and oh, sorry, forgot that that wasn't down there for you. All right, there we go. We'll just make this nice and big for you. Alright, so we've got one root right over here and another root right over here. And if we're going to determine those graphically, again, it's going to be better to turn the grid on, and we can even go, no, that'll be good. Alright, turn the grid on and zoom in. Grab this tool here and zoom in right there. So there's going to be a root right where that crosses. So that's going to be minus 1.19. Let's just call it minus 1.19 because that's close enough. So minus, let's switch colors too so we know. Okay, graphically. So they're going to be, okay, the positive real root. Alright, well, I was going to say minus 1 point whatever, right? But that doesn't do any good. So if we go back to this plot, that bum deal. It turns out they only want this one, right? The positive real root. Okay, fine. So the positive root right here. Alright. Whoops. Alright, so let's zoom in again. Whoa, come on. Sorry about that. Zoom in a few times here. And we're going to get 1.19, right? 1.19, that's our root. 1.19, we'll just go 1.191 even. Okay, so we're going to go 1.191. Okay, that's our guess. Alright, using 3 iterations of the bisection method with initial guesses of lower equals 0.5 and upper equals 2. So 3 iterations. So again, let's do I, XL, XU, F of XL, and f of xu, and get that going here. Woo, okay. And then now we remember we're going to need a little more than this, and then we're going to do xr, which is, that's going to be our guess, which is going to be xl minus xu over 2, and it'll be plus because it's an average. Okay, and then epsilon a, because we're going to need that. Oh, well, so weird they're not having us do epsilon because it's just telling us to do a certain number of iterations. So normally we would compute epsilon a, and then we're going to say iteration 1, 2, and 3. They're going to have us do 3 iterations. Okie dokie, that's our table with my beautiful straight lines. Alright, XL, so we know right away that's 0.5, and I'm gonna do this 0.5, and XU is 2, and f of XL. So in order to do this, let's just let's just take and do it in here. Let's go edit f.m. Let's make a function f, right? And here's the one that we had before, because this file was saved from the previous problem I did. And we can just delete this stuff. Come on. Log x to the 4th minus 0.7. Okay, so there we've got our function f. Perfect. So then if we say XL is 0.5, so 0.5 and 2. So, oops, f of 0.5 is an f of 2. Is that right? Yeah. Yeah, 0.5 and 2. So we have minus 3.4726 and 2.07. So let's just go minus 3.5. Well, no, let's try to write a little more out. Minus 3.47 and minus 2.07. Okay, I can't even remember. Minus 3.4726. And 2.0726. Okay, good. And again, we see we have a sign change here, right? We got a negative and a positive. Good sign. Okay, so now let's take the average of these two. So we're going to say and I don't want to clear the whole thing, so say minus actually we can just do it like this. F of 0.5. No, it's just the average of that. 0.5, hang on, 0.5 and 2. So it's 0.5 plus 2 over 2, right? That's what we've got. That's 1.25. So that is 1.25. That's our new guess. Okay, and now we have to evaluate the function at 1.25. So we say f of 1.25, and that's 0.1926. And so that is 0.1926. The 0 here, of course. And of course that the reason I wrote it here is because that's going to come our upper one, 1.25, The reason I knew it is because this has to be bigger than, we still have to bracket the root. And so if this were negative, I would have put it over here, and our upper limit would have stayed the same, minus 3.4726. We just copy that down, and our lower root, or lower again, is 0.5, and our average is just the average of 1.5. Well, I just think that's 1, right? So 1.5 plus 0.5 is 2, so that's 2 divided by 2 is 1. 1.0. Alright, so that's our new root guess. And well, let's just evaluate the function then at 1.0. Is 0.7 minus 0.7. So the minus 0.7, and it's going to go here because we got to bracket it. Minus 0.7, and this is going to be 0.1926 again. This is going to be then our lower root is going to be 1.0, and our upper is 1.5, and so our guess is going to be 1.1 plus 1.2 5 over 2, 1.25. That looks wrong. Is it wrong or is it right? I see what I did wrong. Sheesh, I can't do one of these problems without doing something wrong. Yeah, our upper has to be our 1.25, not 1.5. So that has to be 1.25. Yeah, let's go f of 1.25. That's 0.1926. 0.1926. Oh, okay, so I had the right value here. I just didn't write in the right value there. So yeah, and so then I didn't take the right value here. Alright, so let's just hold everything. Alright, hold everything. And let's figure out then what the average of 0.5 and 1.25 is. So 0.5 plus 1.25 over 2. Okay, 0.875. So that is our guess is 0.875. That's the average of these two. That's looking a little better. We sort of got lucky that we were still bracketing the root there actually. So, and we don't even know what that is. So f of 0.875 is minus 1.2341 minus 1.2341, and then we have the upper is going to be the same, 0.1926, and that is going to be 0.875, 1.25, and so the average of 0.875 plus 1.25 over 2. It beeps at me because I didn't do that. 1.0625. 1.0625. Alright. 1.0625, 1.91. Those are fairly consistent. Just wanted to look at the difference between those two. That's not too bad. And we haven't really converged here yet, so we might keep going there, but we're getting there, and we're already pretty close, I can tell. Alright, so now using 3 iterations of the false position method with the same guesses. So false position method. Alright. We can probably make a table pretty much just like that. And let's label this. This is the bracketing. And then we have the false position. False position. And we can go ahead and build our table. And let me get the brush to build the table with. Okay, so we have I, and we're going to do 3 iterations. 1, 2, 3. Again. Woo. Okay, and we're going to have an XL and an XU. Sorry, I shouldn't have called that the bisection method. That's silly. They're both bisection methods. Excuse me, they're both bracketing methods. This is not just bracketing. Bisection, of course it was bisection because we're dividing everything in half. Bisection. That's a much more meaningful label. Okay. XL, XU. Let's go f of XL. F of XU. And XR. And XR. Okay, so up here, our root was the lower plus the upper divided by 2. And of course, that was just graphically, remember, that was just, as I explained, that was just taking just doing the halfway point between the x's. Okay, so the false position method, this one is the one where we have the function. Let's just remind ourselves here. This one's the one where we have the function and we evaluate it at one point, and again we have to be crossing the 0 line. So we evaluate it at one point, and we evaluate it at another point. We draw a straight line between those points, right? And then we just say, that's it. Then we just say, that's our guess, right? Where that crosses the axis, that's our guess for the root. And we square that in, and then we see, again, just like we did with the bisection method, then we see which side of the root that actually lies on, whether that's positive or negative, so we still have a change in sign. So that should be enough information now to come up with this formula, right? And so the formula is going to be then, let's see, going to be where it crosses the 0. Alright, well, I'm just going to cheat because the purpose of this isn't to derive it. We do that in the other videos. So that's just going to be f of, it's going to be x r equals xu minus f of xu times, let's scoot over a little bit here too so we got enough room, times xl minus xu divided by f of xl minus f of xu. Okay, and again, that is just simply solving this line segment, that straight line, solving for when that equals 0. So no big mystery there. All right, so XL, again, we're going to use the same things as before. So let's start filling this in. XL is going to equal 0.5. 0.5. XU is going to equal 2. And we're going to have the same thing for FXL and FXU, minus 3.4726 and 2.0726. Alright, now this is going to get a little bit hairy, and so I'm just going to make a function to do all that math for me because I'm lazy. So let's going to call it edit, and let's call it false pause. I'll just call it false position.m. Okay, this is not going to do the whole method or anything, but it's going to give me the guess. So we're going to say function XR, because it's going to be our guess at the root, equals false position okay, and what information are we going to need to pass this? Us no. Oh, because we're just going to x xl xu and then fxl and fxu, right? We're going to need to pass all that information in, and so we're going to say xr equals, and just do this formula, xu minus f of xu times xl minus xu. So it's just going to be xu minus, and then let's put a big parenthesis here because we're going to need to f of xu times xl minus xu, and I'm going to parenthesis that now, and f xl minus f xu. Alright, that's it. That's all there is to it. It's a really simple function there. And then xl, xu, fxl, fxu. So the same order that I did everything in. Lower, upper, lower, upper. So, alright, and then what was our, so 0.5 and 2. So let's go false position 0.5 2.0 f of 0.5 and f of 2.0. Okay, so that's it. That's going to give us our guess 1.4394 1.4394. Alright, so again we're going to use the same method for coming up with our guess as we did before, for coming up with our new limits as we did before. So we're just going to go f of, and let's just call that, I'm gonna give this a name, right? Because that's actually useful. Because instead of keeping track of all these numbers, let's gonna call it xr equals that. So that's a lot better now. And now I can just say f of xr, and that's 0.7568. Okay, 0.7568. So that'll be this limit, 0.7568. And so that means it's the lower one, 1.4394, and so 2 is going to still be our other one, and so we're going to have minus 3.4726, and now we can just evaluate it at those two values, so minus 1.4394 and 2, right? And so I'm going to clear that, and we're just going to say then XL is equal to whatever our XR was, right? So that's our lower, and then our upper was 2, right? So XU equals 2, right? Make sure XU is 2, yes, XU is 2. And then, so we're going to say, remember, XR, false position. And then we're just going to go XL, XU, F of XL, F of XU. And that's our root, 1.1169. 1.1169. And that's pretty good. it's positive, right? I mean, that's our guess, right? Oh yeah, that's our new guess. And we gotta, yeah. So we gotta evaluate the function there. F of XR. That's going to give us. Can you guys see that? Let me see. F of XR. All right, minus 0.2578. So that's going to be this one. So minus 0.2578. Yeah. 2578. Okay. And then this is going to be the same, 0.7568. And this is going to be 1. Yeah, 1.1169. And that's not right. No. Oh yeah, that's right. 1.1169, and then 2, right? Because when that was evaluated, it was minus 3. Yeah, 2. 0.78. Yeah. All right, and now we just have to get our guess, our current guess, and then we're done with our third iteration. And so I'm just gonna go XL equals. And XL is going to equal, well, XL is just going to equal our XR, right? So XL equals XR, and XU equals 2. I think it's just what our previous one was, but we'll put in a 2.0 just in case. And then we can get our new root just by false position, XL, XU, FXL, FXU. That should give us our 1.2146. All right. So 1.2146. All right. So looking pretty good here. I think we're done with the problem. So we can compare our answers to make sure they look good. But we got 1.2146, 1.0625. And 1.191. 1.191. So those are all relatively close to each other. So yeah. So I mean, judging from the graph, which I think is really pretty good in this problem, I think this one's going to be a little closer than this one. But again, I don't know what the actual root is. But anyway, all right. So that is this problem. Actually, I decided I wanted to do one more thing, so let's go hold on. I just want to show this on the plot, show our answers on the plot. And then we're going to go plot right, and it was just going to have an x value. So XR, that's our last guess. And then let's make it a green star, okay? And then plot our previous one, and that was 1.0625, 1.0625, and then we'll make a black star. We'll make it a black plus. How about that? And actually, let's also do F at the value. All right, yeah, let's try that. So let's just show that on the graph. All right, so this was, and we can even do legend. That gets in my way. Come on, legend. Well, that's probably going to be even wrong. Bisection. False position. Yeah, that's not right. Let's try that again. So that we got to do the first two. So legend f of x x equals 0. So we just have to label them in the same order. Make it so you can see that better. We just have to label them in the same order that they were labeled in. So if we go to our plot, then that's better. F of x, x equals 0, the bisection, and the false position methods. Even zoom in a little bit here. So we see that we in fact were closer with our false, well actually we were closer with the bisection method there. Unless I did those in the wrong order. Yeah, I did those in the wrong order because when I plotted them, yeah, so my labels are backwards. When I plotted them in the other order. False position, bisection. That's better. Yeah, that was actually the case. So, because that looks better, right? Because if you look at our numbers here, we've got just less than 1.1, and that was the value. 1.0625 was the value for bisection, and 1.12 or 1.2146 was the other value. So we're getting pretty close. Anyway, that's it for this part.